In this lecture video, we're going to talk about interrupts with the Arduino, multiple files, object-oriented programming, or OOP. Also, we'll introduce electronic components, some of which we've already seen. Study topic goals are to first look at interrupts, and next multiple files, next object-oriented programming, next electronic components and schematic drawings. Finally, we will introduce mandatory MCU homework 2, a motor control circuit. Interrupts are useful, as it says here, for fast response to real-world events. What would those real-world events be? We'll talk about that in the next slide. What happens when an interrupt is initiated is the program stops wherever it is, or actually it interrupts. It doesn't really stop the program, but it interrupts, runs an interrupt handler function, which is a special function which knows what to do in the case of an interrupt. Then once the interrupt has been handled, returns right back where it left off in the regularly scheduled program. For more information on interrupts, this is the URL in the Arduino Playground and has a great tutorial. Let's look at some flowchart examples. This should look familiar. This is a program that we've seen before, this flowchart. Adding interrupts now, an interrupt can interrupt the program anywhere. At this point it's interrupting in the middle of making some decision. Or it can be in the middle of doing some tasks. Or it might be doing some other tasks. At any rate, the program can be executing anywhere when it's interrupted. So the interrupt is asynchronous to the program execution. Two different kinds of interrupts exist. One is an external interrupt. Some change in the state of a pin, typically one of the digital I/O pins, initiates this type of interrupt. Second interrupt is a timed interrupt, which can be set up to run at periodic intervals as determined by timers built into the Arduino microcontroller. First example, external interrupt. MCU can be running a motion control program, maybe running this factory machine here. Perhaps a bit of an exaggeration, but let's say that we are running this machine and someone hits the emergency stop button. It's necessary to handle that quickly and to stop the motor, stop the machine quickly. So the e-stop might be connected to an external interrupt. Second example is a timed interrupt. Maybe a PID controller handling some motion control, such as what's shown in the right here, but won't be explained in detail here. PID controller would need to sample whatever it is that we're controlling, whether it's the speed or position or temperature. You need to sample that process variable periodically at timed intervals for accurate integral versus time summation. Next, let's understand how external interrupts are handled. This is the hands-on example that you'll be doing in class very soon, Lecture 5, Demo 1. What you do is connect and disconnect a jumper between digital pin 2 and ground. This goes through the details of uploading the sketch, connecting one side to ground, activating the serial monitor. Remember, this is done through the menu, Tools option. Then, physically, the person plugging and unplugging the jumper should count the events, should count how many times they plugged and unplugged. Then, the system will print out on the serial monitor how many counts it saw, debounced, non-debounced, and interrupt handled. These numbers should be different. And the one that should show the highest count should be the one that was handled by the interrupt, because the interrupt handling is the fastest, and it would be less likely to miss any counts. Taking a little bit of a look at the program here. Again, this is the one that you'll be doing hands-on, Lecture 5, Demo 1. Volatile keyword is necessary. Why is that necessary? Because the interrupt function is going to be writing to this variable, and also the main program is going to be reading that variable. The volatile keyword is necessary because that variable may be changed from anywhere in the program. That's the easy answer at this point. Down here we see how the interrupt itself is attached. Right in the middle, this middle parameter, input scene, that is the arbitrary name that we've assigned to the interrupt handler function. This function is going to execute when a certain pin changes state. What pin is that? Right here, this jumper input. This is something that we arbitrarily made up at the top. We said jumper input is called 2, or defined as 2. So what we're saying is when pin 2 changes, we want the input scene function to execute. Hold that thought. We'll see the input scene function in just a little while. Looking at the main loop, what we have is first the code that handles the no debounce. This is going to be an input that's changing a lot of times, and it adds that up, calls it the total jumper transition scene. We have three different variables. One is going to store the total number of counts that are not debounced. Also, we're going to do some debouncing and store that count state in a debounced input, whereas the total debounced jumper transitions right there. That is going to store the number of debounced jumper transitions seen. Next, let's look at how it's handled in the interrupt function. Quick and easy. Input seen is the name of the function. Again, that changes if the jumper is plugged in or if it's bouncing at all. Remember how noisy a bounced edge can see? This interrupt should see every one of those transitions, should run this interrupt handler function, and should increment the appropriate variable. Then what the program does is prints out every one of those counts. The non-debounced, the debounced, and the ones that were seen by the interrupt handler. That one should, again, be the highest count. So the third of these should see the most transitions of that bouncing input. So for the hands-on time, you'll open the lecture demo, you'll read through it, upload it, and test it. Again, on the previous slides, the previous minutes here, we have described that program in detail. So looking through it, uploading it, testing it should make a little bit more sense now.